Hello friends. So in the last class, in the last video, we have seen some examples based on the continuity. Okay, so I am going to start with the same, that is exercise 5.1. See, from the exercise, I am not going to solve with all the questions. Okay, I am going to select some randomly such questions which are different from each other. Okay, and which are the similar, those I will just skip it. Okay, so you can work out as a homework. Okay, so the next example I am going to take to check the continuity, that is f of x is equals to 1 divided by x minus 5, where x is not equals to 5. F of x is equals to 1 upon x minus 5, where x is not equals to 5. If you see the question, so in this continuity point is not given. Continuity point is not given. Okay. So whenever the continuity point is not given, then what we have done? That is, we have to assume one continuity point. That is what usually we take it as C. Okay. But see, here one condition is given. X is not equals to 5. Why this condition is given? Because from that set of real numbers. Okay. Suppose if you take x is 5. X is 5, what will happen? If I put x is 5 here, 5 minus 5 will be what? 0. Then 1 by 0 is infinity. That is, function is not defined. Okay. So therefore this x is not equals to 5. So therefore you write clearly the function is defined for all points, okay, in real number. Okay, so this clearly the function is defined for all the points in the real number except 5. Except 5. Why except 5? Because at 5 this function is not defined. So therefore domain of f, okay, that can be written as df. Okay, because always we choose those continuity point from the domain. Okay, so domain of f, that is df, is equals to r minus singleton 5. R minus singleton 5. So r minus singleton 5 means what? From the set of real number, 5 is deleted, means 5 you have just neglected. Okay, so therefore it is r minus 5. So now you have to choose a real number. So let's see, belongs to df be any real number. Be any real number means you have to choose one real number from that set of real numbers, right? So but your set of real number is what now? R minus 5. So that r minus 5 is df. So I have taken here df. See, this is a simple function, so you have to use the continuity first definition. So first you have to calculate f of c. Okay. Now in the place of x we have to put c. So therefore 1 upon c minus 5. 1 upon c minus 5, and limit x tends to c f of x, which is equals to limit x tends to c f of x is what? 1 upon x minus 5. Okay, or which is equals to, substitute the limit as x tends to c. So answer is 1 upon x minus 5. Okay, so if you observe f of c value and limit value both are same. So therefore limit x tends to c f of x is equals to f of c. And when this condition is equal, then function is what? F is continuous. Function is continuous. Okay, this is one example. Next example I am going to take is, that is f of x is equals to modulus of x minus 5. F of x is equals to what? Modulus of x minus 5. But as you know, in the first year you have studied that function, modulus function. Always that modulus function gives the two values, plus and minus. mod x is plus x when x is greater than 0, mod x is minus x when x is less than 0. So first we will find the limit point here. How to find that limit point? See, function is modulus of x minus 5. So this value will be always greater than equals to 0. Why? Because having modulus sign means what? Always it gives the positive value. Therefore greater than equals to 0. I'll remove this modulus sign. So I will get x minus 5 is equals to 0, or x is equals to what? 5. X is equals to what? 5. So this is your limit point. This is your limit point. So using this limit point, this mod function we have to define. Okay. So let us define that. So therefore f of x is equals to, okay. Now it is having two values. One is plus, one is minus. So this x minus 5, I will take it as positive. Okay. Here x minus 5 is positive when if x is greater than or equal to 5. That is your limit point. And this minus x minus 5 if x is less than 5. So this is positive when greater than or equals to 5. This is negative when x is less than 5. Now we have to check the continuity. So I told you, when the function is defined in the form of less than and greater than and continuity point is not given. In this also continuity point is not given. Then we have to follow with 3 steps: greater than, less than and equal to. Okay. So first we will take continuity point is not given. So you have to write one sentence that is fixed for all the examples where the continuity point is not given. Clearly the function is defined for all points in real line. In real line, or you can say real number. The both meaning is same. Okay. So let assume that continuity point C belongs to R, be any real number. Means from the set of real numbers I have chosen C is the real number. Okay. Now, so let us check the conditions now. So first condition is if C is greater than 5. If C is greater than 5. So I told you in the first two conditions we have to use the first definition only. So for C greater than 5. Okay. So I will take f of C is equals to. Now for greater than 5, here it is greater than 5. So greater than 5 function is x minus 5. But in the place of x I am having C. So the function becomes C minus 5. Okay. And limit x tends to C f of x, which is equals to limit x tends to C. Again for greater than 5, f of x is x minus 5. Now put the limit is x tends to C here. So answer is C minus 5. So f of C value and the limit value both are same. So therefore limit x tends to C f of x is equals to f of C. So whenever this condition is equal, then your function is what? Continuous. So f is continuous. Okay. At every point. But what condition? Greater than 5. Greater than 5. Okay. Next, second condition. If C is less than 5. If C is less than 5. So again, as usual, we have to check f of C first. Now C less than 5. So for less than 5, condition is what? A function is what? Minus of x minus 5. But in the place of x, what I am having? C. So take the same function, but you have to put it x as C. So the answer is minus of C minus 5, or which is equals to, take minus sign inside the bracket. So the sign will change. The plus C will become minus C, and minus 5 will become plus 5. So the answer is 5 minus C. Okay. And you have to check the limit x tends to C f of x, which is equals to limit x tends to C f of x is what for less than 5? Minus of x minus 5. So which is equals to, put the limit as x tends to C. So minus C minus 5. Okay. So So when you put the limit as when you take minus and inside the bracket, again the answer is 5 minus c. So if you see this and this again same, so therefore limit x tends to c, f of x is equals to f of c. So therefore what? F is continuous at every point less than 5. Okay, so as usual I told you, in the first two conditions the function will be always continuous. The third condition will decide the given function is continuous or discontinuous. Okay, so I will take third condition at c is equals to 0. At c is equals to 0. So whenever you use this, sorry, not 0, I think limit point is 5. Limit point is 5. Okay, so whenever you take this third condition, in that we have to check always LHL and RHL. So before checking with LHL and RHL, first we have to calculate f of c, but c is 5. So f of 5, which is equals to, now for equals to 5, see here, equals to 5, function is x minus 5, but what is x here? 5, so 5 minus 5, so 5 minus 5, answer is 0. Okay, next we have to find LHL. Definition is limit x tends to c minus f of x, which is equals to limit x tends to c is 5, so 5 minus, okay, f of x we have to write. LHL means what? Less than. So for less than, function is minus of x minus 5, or which is equals to, substitute the limit x tends to 5, so minus of 5 minus 5. So 5 minus 5 is 0, but don't write answer is minus 0, you just write 0 because it is a neutral number. And RHL, so RHL is equals to limit x tends to c f of x, limit x tends to c plus f of x, which is equals to limit x tends to 5 plus, now RHL means greater than, and for greater than 5 function is x minus 5. Now put the limit is x tends to 5 here, so that is 5 minus 5, answer is again 0. So if you observe, f of c, LHL and RHL all are same, so therefore f of 5 is equals to LHL is equals to RHL, so all are equal, means what? F is continuous. F is continuous. Okay, so this is one example I have solved here. Next question. Next question I am going to solve is what? That is something different now. Okay, f of x is equals to x if x is less than equals to 1, and f of x is 5 if x is greater than 1. If x is greater than 1, is continuous at x is equals to 0 question mark, x is equals to 1 question mark, and x is equals to 2, and x is equals to 2. Okay, so you have to check the continuity of this given function at 3 continuity points. Okay, but here I will give you the difference. Okay, if you see the function, it is given in the form of less than and greater than, so you might think that we have to use the second definition of continuity, that is LHL and RHL. Okay, but this is not possible for all the continuity points. When we can use that LHL RHL definition? Whenever this limit point and the continuity point is same. Now in this all the 3 continuity points, this is 0, this is 1, this is 2. Okay, so which will be equal to that limit point? Here limit point is 1, so continuity point is, here it is 1. So limit point and continuity point is same. In that case, you have to use the LHL and RHL definition, otherwise our simple definition. Okay, so let us see now. So at x is equals to 0, So this continuity point and limit point is different from each other. So therefore you have to use the first definition. So first definition is what? F of c is equals to, here c is 0. Now at x is equals to 0. So 0 comes under first condition or second condition. Second condition is x is greater than 1. So number starts with 2, 3 and so on. Where x is less than 1. Less than 1 means 0, minus 1, minus 1 and so on. So 0 comes under first condition. Therefore your function is what? X. But here x is what? 0. So answer is 0. Okay. And limit x tends to c, f of x is equals to limit x tends to 0, f of x is again same, that is x. So when I put the limit is x tends to 0, answer is 0. So both are same. So therefore limit x tends to c, f of x is equals to f of c. So therefore what? F is continuous at x is equals to 0. Okay. Now this third continuity point at x is equals to 2, that you work out as a homework. Okay, how to do this now? At x is equals to 2 means what? It comes under second condition. Okay, otherwise I'll do this. I think that second I'll give for homework. So at x is equals to 2. Okay, so first you have to calculate f of c is 2, so f of 2 which is equals to, now x is equals to 2 comes under second condition. Second condition is what? Function is what? 5. But here x is what? 2. See, in this 5 we don't have x variable, so you can't put this 2 value there. Okay, so therefore f of 2 value will be as that 5 as it is, means 5 will keep as it is. Okay, and limit x tends to c, f of x is equals to limit x tends to 2, f of x is what again? Same. Okay, so here again it is not possible to substitute the limit. See, x tends to 2, but we don't have x variable, so we can't put the limit. But in the limit chapter in the first year we have studied, in the limit, if this function is constant, then always that constant function itself is the value of the limit. So therefore 5 is the answer. So f of c and limit again both are same. So therefore limit x tends to 5, f of x is equals to f of 5. So therefore f is continuous at x is equals to 0. Oh sorry, x is equals to, how much it is? 2. At x is equals to 2. Okay. Now this third point you carry out, that is how to solve this now. At x is equals to 1 means what? First you have to calculate f of 1, then LHL and RHL. Okay. So I hope that you have understood this example. Thank you.